this review, probably just going to do about one from each of these little sections on the study guide. We can do more if we need to, but we want to save as much time as we can for the test and the knowledge check. So we'll just go through them. We'll start with 1 to 4 here. 1 through 4, any of those you want to see up here? Or do you want me to pick one? Skew. Which one is skew? 4? All right, number 4. They want all the segments that are skew to CD. Skew means they're going to be on different planes and not intersect with CD. CD is down here on the bottom. So we have to be on a different plane and not intersect with that. So one of them would be FG, because it's going up and down, while DC goes left and right. Those two are on different planes, they don't intersect. And then same thing with EH, it's going up and down while DC goes left and right. Those two don't intersect, they're on different planes. There's 2 others. We can go with AE. AE is going front to back, while DC is going left and right. Those two are on different planes, they don't intersect. Same thing with FB. So there's your 4 lines that would skew to CD. What's that? 3. Number 3. All the segments that intersect GH. Intersect GH means it's going to touch GH. So GH is back here. We want every segment that's going to touch GH. CG would touch GH. So would DH. So I'll start with those 2. Those 2 are both coming from the front, touching it in the back. Then there's 2 that come from the top and touch it, coming down from the top here. EH and FB or FG. Those intersect with HG. Anybody need 1 or 2? All right, let's go to 5 through 10. Any requests on those, or do you want me to pick one? Not on that. Okay, let's just randomly, let's go with 8. On this one, they want us to identify the transversal connecting each pair of angles and then classify the relationship between them. That's where we're going to use our special angle names. 13 and 10, if I look at 13 and 10, those 2 are right here. Now, first thing I want is the transversal. The angle that, or the line that goes through both angles 13 and 10 would be line K. So that's going to be our transversal. That's our first answer. And then the kind of angles 13 and 10 are, they're both inside the 2 lines being intersected. And they're on the left-hand side of the transversal. That makes them consecutive interior. You can do some abbreviating on the test if you want to. Yeah, because they asked for the transversal up here. They want transversal and they want consecutive interior. All right, any others on 5 through 10 you want to see? Okay, let's go down to 11 through 16. Any requests on 11 to 16? 12. All right, circle that. We'll come back to it in a second. In the picture, angle 9 is 80, so I'm going to mark that. And angle 5 is 68. We know those 2 angles. It wants to find the measure of each angle and then tell which postulate or theorem we used. Now, when you look at this picture, the other thing you need to notice is these 2 little arrows, 2 little triangles here. That tells us these 2 lines are parallel. W and V are parallel. So those are the 2 parallel lines we're going to use. And then we have 2 transversals coming through. So with number 12, we want to find angle 1. Angle 1 is right here. And since that's kind of on the top transversal, I'm going to cover up the bottom transversal. And that makes it a little bit closer to what you're used to seeing normally. So we've got our 2 parallel lines. Here's our transversal. Angle 1's right here. And its corresponding angle, the angle 9, is 80 degrees. So we know our theorem. If the lines are parallel, our corresponding angles are congruent. Since angle 9 is 80, angle 1 would have to be 80. And then again, they want us to tell which postulate or theorem we use. Those are corresponding angles. So we're going with the corresponding angles postulate. Any others you want to see on 11 to 16? Yep. 11, they want angle 12, which is right next to the 80. So on this one, The 80 and the 12 are a linear pair, which they form this straight line. And we know a linear pair will always add up to 180. So if angle 9 is 80, we take 180 minus 80, we get 100 left over for angle 12. And the reason for that, those two are a linear pair, which means they add up to 180. Supplement theorem says if you have a linear pair, then they add up to 180. Any others you want to see on 11 to 16? 15. Angle 7. Angle 5 and 7 are vertical angles. Since angle 5 is 68, angle 7 would also be 68. We said those are vertical angles. That's the vertical angles theorem. Now, again, on these, your reasons for your justifying part here, a lot of times there's more than one correct answer. So like here, I saw vertical angles right away. That's why I went with vertical angles. It's possible there could be another way of doing it. So you could have another different answer down here. That will be possible sometimes. Any others you want to see on 11 to 16? All right, how about 17 to 20? 19, they want us to find, or they want us to determine whether MN and RS are parallel, perpendicular, or neither. They're going to be parallel if they have the exact same plane, or exact same slope. They're going to be perpendicular if they have opposite slopes. Opposite slopes means they're different signs, one's positive, one's negative, and then their fractions are going to be reciprocals of each other. And if neither of those two things happen, then our answer is neither. So let's start with MN. To find the slope of MN, I'm going to use the points M and N, because those are the two letters we use to name that line. Abbreviation for slope is an M. And to find slope, we're going to subtract the y's over the x's. My y coordinates are 4 and 3. So I could either go 3 minus 4 or 4 minus 3. It doesn't matter. I'm going to go 4 minus 3. Now, whichever order you do it on top, you have to do the same order on the bottom with your x coordinates. Your x coordinates are -1 and 4. Since I went 4 minus 3, I have to go 4 minus -1 on the bottom. And then 4 minus 3 is 1. Double negative here becomes positive. Slope of MN is going to be 1/5. Then we'll do the same thing to get the slope of RS. Slope of RS, we're going to use points R and S, because those are the two letters we use to name that line. And same exact thing here. We're going to subtract y's over the x's. I'm going to go the opposite direction this time. Our y coordinates are 1 and 2. So this time I'm going to go 1 minus 2 for the y coordinates. And then the x coordinates on the bottom, we'd have to go the exact same order. 3 and -2 are your x coordinates. So we're going to go 3 minus -2. 1 minus 2 is -1. And then a double negative here becomes positive. 3 plus 2 is 5. All right, then we got to figure out if they're parallel, perpendicular, or neither. They're parallel if they're the exact same plane. These two are not the exact same. One's positive, one's negative. They're perpendicular if they're opposites. That means they have different signs, which these two do, and your fractions are reciprocal of each other. But these fractions are not reciprocal of each other. So that doesn't make them perpendicular. So your only option left is to say they're neither. So if neither of those two happen, if they're not parallel, they're not perpendicular, then you got to go with neither. Any others you want to see on 17 to 20? 18. All right, same deal, MN. We're going to use points M and N to get that. Oops. Slope of MN. Y is over the x's here. I'm going to go 5 minus 3 for my y's and 0 minus -1 for the x's. 5 minus 3 is 2, 0 plus 1 is 1. So there's the slope of MN. Slope of RS, again, we'll use these points R and S. And we're going to subtract the y's over the x's. I'm going to go -1 minus 1 for the y's and 6 minus 2 for the x's. -1 minus 1 is -2, 6 minus 2 is 4, and then this reduces to -1/2. Now, if you look at these two slopes, you have 2/1 and -1/2. Those two are opposites of each other. They have different signs, and their fractions are reciprocals of each other. When they're opposites of each other, that makes them perpendicular. So you can either write out perpendicular, or you can use the symbol for perpendicular. Either way is fine. Anybody need to see 17 or 20? All right, flip it to the next page. And we'll start with 21 to 24. Any of those you want to see? 24, all right. 24, well, first of all, the directions tell us we're going to determine which lines, if any, are parallel, and then state the postulate or theorem that justifies the answer. So on 24, they're telling us that angle 5 and angle 12 add up to 180. Angle 5 is right here, angle 12 is right here. Those two are consecutive interior angles. Since those are on the right-hand side of the picture, I'm going to cover up the left-hand transversal, because I don't need that. So now my picture kind of looks like what we're used to seeing. 5 and 12 are consecutive interior angles. And our theorem says if the consecutive interior angles are supplementary, then the lines are parallel. The two lines that would be parallel would be L and M. And then we got to name our theorem or postulate that goes with it. These are consecutive interior angles. And so this one's going to be the converse of the consecutive interior angles theorem. On the test, if you just call it consecutive interior angles theorem, I'll be fine with that. As long as you identify we're using consecutive interior angles, you should be good. So technically it's the converse, although you could just say consecutive interior angles theorem also. Anybody need to see another one of those? 23. 2 and 16 are congruent. So 2 and 16, now we're on the left-hand side of our picture, so I'm going to cover up the right-hand side. 2 and 16 would be alternate exterior angles. And we're saying that those two alternate exterior angles are congruent. So we have the theorem that says if the alternate exterior angles are congruent, then the lines are parallel. Those two lines are L and M again. And since they're alternate exterior angles, this is the converse of the alternate exterior angles theorem. And again, if you just called it alternate exterior angles theorem on the test, that would be okay. As long as you're identifying that we're using alternate exterior angles, I'm good with that. Any others on 21 to 24? Okay, let's go down to 25 to 30. 25 to 30, we're going to find x so that L is parallel to M. And also identify the postulate or theorem we use. So we have to find the one value for x that's going to make the lines parallel, and then come up with our theorem. Any of those you want to see? Yep. 25. All right. 25, we've got a 5x minus 5 and a 6x minus 20. Those two are alternate exterior angles. In order for the lines to be parallel, alternate exterior angles have to be congruent. So for our equation, we'll just put these two equal to each other. And then we have to solve it. I'm going to subtract 5x from both sides. Those disappear, leaves us a negative 5 on the left. 6x minus 5x is 1x. And you got the minus 20 here. And if we add 20 to both sides, negative 5 plus 20 is 15. And we got the x here. Negative 20 plus 20 becomes 0. So x is 15. That's one of the answers they wanted. X would be 15 to make those lines parallel. And then they want the theorem or postulate. Since those are alternate exterior angles, this is your alternate exterior angles theorem. Any others on 25 to 30? 27. We have a 3x plus 15 and a 90-degree angle. And those two are alternate interior angles. So if you go back to your theorem sheet, in order for the lines to be parallel, alternate interior angles have to be congruent. So again, we'll put those equal to each other. 3x plus 15 would equal 90. We subtract 15 from both sides, we get 3x on the left. Those disappear. 90 minus 15 is 75. And 75 divided by 3 is 25. So x is 25. That makes the two angles congruent, which makes the lines parallel. And the postulate or theorem, those were alternate interior angles. So we have the alternate interior angles theorem. Any others you want to see on 25 to 30? Okay, now that extra page we gave you the other day, we're going to go through both of these. These we have to come up with the proof and come up with the proof all by ourselves. There's going to be 4 steps to this. On the test you're going to take here in a little bit, you're going to have a fill in the blank proof. But if you can do these all by yourself, that's going to make those fill in the blank proofs a lot easier. So I'm going to set it up here. I'm going to abbreviate S for statements, R for reasons. And on this one, we're given that P is parallel to R. So I'm going to start with that as my first step. P is parallel to R. And I'm going to go ahead and mark that on the picture. P and R are these 2 lines. They're going to be parallel to each other. It says it's going to take us 4 steps, so I'm going to go ahead and put in 4 spots here. All right, we took care of the easy step. The first step's the given. Now, we want to prove that angle 1 is congruent to angle 8. And at this point in my proof, do I have angle 1 in the proof? Nope, I haven't put angle 1 in the proof yet. So let's go to our picture. Now, there's more than one way to answer this. So there could be a couple different answers here, which is going to make this proof. There's more than one way to do this proof. But if you look at the picture, what's one angle that angle 1 would be congruent to? 1 and 5, yes. What kind of angles are 1 and 5? They're corresponding angles. We have the theorem that says if the lines are parallel, then the corresponding angles are congruent. So we could go this route. 1's congruent to 5 by the corresponding angles postulate. And if you want to mark it in your picture, you can do that. And what that step has done is it's gotten angle 1 into our proof. So we're halfway there. We also need to get angle 8 in the proof. So let's look at the picture. In our picture, can anybody figure out an angle that 8 is congruent to? 5. 8 and 5 are what kind of angles? Vertical. Vertical. So we could say that angle 8 is congruent to angle 5. And by the vertical angles theorem. And if you want to mark the picture, you can. And now we have everything we need in these 2 steps to get the angle 1 congruent to angle 8. Since angle 8 is congruent to angle 5, I can take angle 8, put it in here for angle 5. When I do that, I get angle 1 on the left still. Angle 5 on the right becomes angle 8, which is what we wanted to prove. And we need our reason. What reason allows us to take one thing out, put another in for it? Substitution. There we go. Now, the second proof is going to be almost identical to that. So again, if you can do this all by yourself, it's going to make the proof you do on the quiz or on the test quite a bit easier. Again, we're going to have 4 steps to this one. And there's a pretty good chance you guys can come up with every step yourself. First step, what are we going to do first? Start with the given. P is parallel to R again. I'm going to mark the picture. P and R are parallel to each other. There's our first step. For step 2, we want to prove that angle 3 is congruent to angle 6. At this point in our proof, have we got angle 3 into our proof yet? Nope, we don't have angle 6 either. Let's start with angle 3. Looking at your picture, what's one angle? There's more than one way to answer this. What's one angle that angle 3 is congruent to? We go 3 and 7 again. We could go corresponding angles. Since the lines are parallel, the corresponding angles will be congruent. That's the corresponding angles postulate. That gets us angle 3 into our proof. We also need to get angle 6 in the proof. We don't have that in here yet. Looking at your picture, what's angle 6 congruent to? 6 and 2 would work because they're corresponding. That's one way to answer it. 6 and 7 would work also. Why would 6 and 7 be congruent? Vertical angles. Since we already have 7 in here, let's go with 6 and 7. 6 is congruent to 7 by a vertical angles theorem. And if you want to mark the picture, you can. Now, the reason we went with 6 and 7 here is because now you get angle 7 in here twice, which is going to allow us to substitute. Since angle 6 is congruent to angle 7, I can take angle 6 and put it in for angle 7. That's going to change it to step 2 to angle 3 on the left. Angle 7 on the right is going to become angle 6, which is what we wanted to prove. Substitution allows us to put one thing in for the other. So pretty much the exact same proof we just did.
So like, could we do it backwards? Like start like 3 is congruent to 2, and then, or
Yeah, you could do that.
vertical angles, and then
Yeah, there's more than one way to do this. Yeah, you could have done 3 to congruent to 2 by vertical angles, and then 3 and 7 by corresponding angles. Yeah. So there's more than one way to do it, and there's more than one correct order to do it. Now, today you don't have to worry about that. They're going to give you the order. You're just going to fill in some blanks, which will make it easier. But eventually, yes, we'll have to do that. And the order, doesn't matter which order you put the steps in typically. Any other questions with that? Yep.
So on the answer key, it said number 4 would have been transitive. What's the difference between substitution and?
You could use transitive here also because you have 3 is congruent to 7 and 6 is congruent to 7. Since they're both congruent to 7, that makes them congruent to each other. That's what the transitive property says. If A equals B and B equals C, then A equals C. So yes, you can do transitive here also.
But either one works.
Either one works. Did I spell transitive right? Either one would work. You could look at it as substituting one in for the other. That works. Or you could do the transitive property since they're both congruent to 7. So yes, either one is fine. Any other questions with that? Okay. Now we're going to have till what time do we get out? 10:35. Am I on the right day? Today's Thursday. 10:35. That doesn't look right. We get out at 10:35.
Yes.
Okay. We don't have much time to waste then. We're going to give you about 5 minutes here to do a couple things. You can turn in those assignments.